So, welcome to all once again to the third day of this program, ATAL FDP on our topic advances in solar photovoltaics and its design for e-vehicle. So, today we will be discussing about the design of an grid connected solar photovoltaic system. Now, this is very important as far as solar photovoltaic subject is concerned, that how to design the solar photovoltaic system and particularly grid connected system. Okay, and then the next lecture will be on the design, the fundamental of electrical vehicle. Okay, so today is the third day and we will start with our topic called the design of a grid connected solar photovoltaic system. Basically, we can call it as a microgrid system. Okay, so microgrid system means a small system, uh, not a bigger large system as we have like a Kota thermal power substation or Mahi hydropower substation. These are megawatts uh, power station, but here today we'll be talking about that can be installed, that solar photovoltaic plant that can be installed in our domestic places also, our residential places also. Okay, and no doubt their high level can also be installed in places where there is a large abundance land is available, or in industries or all this. Now, as far as our institute is concerned, in our campus of College of Technology Engineering, we have a 545 kilowatt of solar photovoltaic plant, and that is all grid connected. Hence, we will be more focusing on the grid connected plant. And uh, in this grid connected plant, okay, we will discuss about that how a common person can design it. No doubt, to design it and to proper give a suggestion about it, how much kilowatt you can install on your residence or this, there is a requirement of uh, complete technical knowledge is there. But today my lecture will be in completely in a layman language, so that anybody who has a knowledge of electrical engineering, okay, then he can also design its own grid connected system, solar PV system. Okay, so let us begin. First of all, so my voice is clear, I think so. So
Yes, sir. Clear.
okay, sir. Thank you, sir. So we should get acquainted with what we will be using while designing. Okay. Though theoretically we have learned it, that what are the different components of a solar PV system. But now for your sake, I think so, sir. PPT is visible? No, not
No,
visible.
sir.
Okay, sir. Then I should. Uh, Now I think so. It is visible. Okay, so this is the topic, design of a grid connected solar PV system. Okay, so first of all, let's have a look towards the some components which are being shown on your screen, that what these components will be useful in designing. One is the PV module. Okay, PV module, we have already discussed about it, that this is consist of silicon, either monocrystalline or polycrystalline. And in my very first lecture, I have told you that now the technologies of monocrystalline and even monocrystalline also bifacial, these modules are now common in the market. Okay, though the efficiency has increased by 5 or 10%, but still we are not able to reach 40% of the efficiency. Then another is the battery system. Though in our grid connected system, we never use the battery system, but it is also part when we go for standalone system. Okay, जब हम standalone system पर बात करेंगे तब हमें बैटरी को भी लेना पड़ेगा, और जब बैटरी को लेना पड़ेगा तो बैटरी के साथ एक और कंपोनेंट है जिसको मैं बताना चाहूंगा, वो है ये चार्ज कंट्रोलर. देखिए, ये बड़ा इंपॉर्टेंट कंपोनेंट है. और बैटरी अगर ओवरचार्ज हो गई या डीप डिस्चार्ज में चली गई, नाउ बैटरी विल बी नो ऑफ यूज. ओके, ओवरचार्ज में इट कैन बर्स्ट, deep discharge mein it is very difficult to regain it. Therefore there is a another device, that is charge controller. We keeps on monitoring the charging and discharging of the battery. So that is in standalone system. Now we are talking about grid connect system without battery. Okay, but then also I have shown it so that as an engineer you should know it what are different components. Now this is inverter. Okay, this is the inverter, which is a very important part either for a standalone system or for grid connect system. In grid connected system, it is being mainly used. Why? Because this module is producing DC. Okay, and in our residence or our industry we are getting AC. Okay, so there is a power electronic device, okay, which Dr. Sujit had talked about yesterday. That is this inverter. So this inverter convert DC into AC, and thereby now it gives to our grid. Okay, and therefore the system runs. Moreover, one important point is the inverter is the frequency. Okay, your grid can run only, you can supply to the grid. Grid means one is coming from the plant, plant like thermal plant or from the hydro plant or from the nuclear plant. अच्छा, एक चीज मैं आप सभी को बता दूं, ठीक है, ये बहुत इंपॉर्टेंट पॉइंट है. When you will come to the practicals in the offline mode, then I will show you the power map of Udaipur. One of our student under my guardianship have developed power map of Udaipur. So since most of them are from Udaipur only, therefore I will say that you know that from where we are getting electricity. हमारा जो ग्रिड की इलेक्ट्रिसिटी आ रही है हमारे उदयपुर में कहाँ से आ रही है? तो इन जनरल एक मिसनोमर है कि कोटा से आ रही, कोटा थर्मल पावर स्टेशन से आ रही, मगर ऐसा नहीं है. It is coming from Rawatbata, from Rawatbata Atomic Power Plant. 2 units are generating electricity, and they are being providing feeding it to the our 220 kV GSS Debari. So this is a very important point. You should know it, that it is coming at 220 kV Debari, and from Debari it is being given to the different 132 kV substation, like Sukher substation. Another substation is at Pratap Nagar. So it is coming to Pratap Nagar 132 kV substation. It is stepped down, and from Pratap Nagar it is coming to the 33 kV substation. And you will surprise to know that where is 33 kV substation? Nearby university area is lying. It is at the Bora Ganeshji area. Okay, and from there it is again stepped down to 11 kilovolt, and then it is coming our university campus, our college campus. Okay, and thereby we put a distribution transformer from 11 kilovolt to 440 volt, and then we get the 440 volt supply to the different buildings of the institute. So that's how the grid is running. So if we connect, if we want to connect our solar power to the grid, it has to be converted into AC, and that of the frequency 50 Hz, because the grid supply frequency is how much? 50 Hz. So there should be a matching between the frequency of the two power sources. One is solar power source and another is grid power source. So this inverter function is not only to produce AC, but that AC of the 50 Hz frequency. Moreover, later on I will discuss also that this grid is to be provided with a sensor, that as soon as this grid, the grid supply goes off, जब हमारी लाइट चली जाती है तो सोलर हालांकि जनरेट कर रहा है लेकिन ग्रिड को वो सप्लाई बंद कर दे. अब आप पूछोगे सर ग्रिड को सप्लाई क्यों बंद कर दे, हमें तो जरूरत पड़ती है, लेकिन ये प्रोटेक्शन सिस्टम है. यदि ग्रिड चलता रहा, अगर ग्रिड बंद हो गया और सोलर ने अपना फीड करना शुरू कर दिया तो रिवर्स में आपकी सप्लाई चालू हो गई. और अगर मान लो ग्रिड पे कोई काम कर रहा है कोई व्यक्ति, तो वो सोलर के ने जो सप्लाई दी है वो उसके बॉडी को टच हो जाएगी एंड ही विल बी नो मोर. सो इट कैन अ फेटल एक्सीडेंट इफ द सोलर कंटिन्यूज इन केस द ग्रिड बिकेम ऑफ. तो इसलिए ग्रिड ऑफ हो जाता है तो हमारा सोलर भी यूं जनरेट कर रहा है मगर ग्रिड से डिस्कनेक्ट हो जाता है, तो उसकी हमारे पास कोई रीडिंग नहीं आती है. तो ये प्रोटेक्शन के लिए कर रखा है, लेकिन आप उस समय हम एक बैटरी लगाकर हम उसके पावर को स्टोर कर सकते हैं. दैट विल बी अगेन अ कॉस्टली आइटम. So many things are there. So one has to optimize the things, that which to take into consideration and which not to. So inverter, PV module, storage battery, charge controller, but there we are not discussing. Then comes the solar array mounting system. Okay, this is also a part where these panels are being installed, and then later comes the cables and connectors. Now two types of cables will be there, because this PV module is generating DC I have already told you. So to give this power from module to inverter, we require DC cables. Okay, then inverter is generating AC. Okay, and this AC is to be provided to the grid. So being AC in nature, therefore will require AC cables. So two types of cable, DC cables and AC cables will be required, and their corresponding connectors. Okay, so when PV modules through cables will come to inverter, there will be different types of connectors are there. These are the solar connectors. Okay, so they will be connected, and that will be connected to our inverter, and the inverter will convert into AC of 50 hertz, and then we will try it to the grid, and we will get the supply to the grid. तो ये मेरे ख्याल से ये सारे आपको पिक्चर समझ में आ गए होंगे. ये अगर आपके दिमाग में अगर सेट है, मॉड्यूल, बैटरी, इन्वर्टर, the charge controller, solar mounting system, cables and connectors, then I think so you will have faced no problem in understanding the solar system. So next come after this, design and sizing principles. Okay, so we have two types of grid connected and two system, grid connected system and standalone PV system. So my focus will be on grid connected system. In generally grid connected system, particularly in India, we go for without energy storage. That is, no battery is being provided. Okay, and it has a great advantage because it provides supplemental power to facility loads. Okay, so when this my grid connector is connected to the grid, okay, so it is providing a supplemental power, okay, to facilitate our loads. So our what happens if you install a grid connected at your home? अगर आप अपने घर में एक ग्रिड कनेक्टेड सिस्टम लगाते हैं तो क्या होगा, आपके बिजली के बिल में कटौती आएगी. ये एक लेमैन की भाषा में मैं समझा सकता हूँ. ठीक है, बिजली के कटौती क्यों आएगी? क्योंकि कुछ आपने ग्रिड से लिया और बहुत कुछ पोर्शन आपने सोलर से लिया. तो जो सोलर से लिया है उसकी काउंटिंग नहीं होगी, केवल काउंटिंग किसकी होगी? जो आपने ग्रिड से लिया है, और इस प्रकार आपका बिल रिड्यूस फॉर्म में आएगा. तो अभी सभी लोग रेजिडेंशियल फॉर्म में जा रहे हैं. ठीक है, ये अच्छी बात है. और अगर पीवी आपका फेलियर हो जाता है तो आपके लोड पर कोई फर्क नहीं पड़ेगा. पीवी फेलियर हो गया तो इसका मतलब ये नहीं और पीवी फेलियर हो गया तो अब यार अब लाइट नहीं आएगी घर में. नहीं, ग्रिड दे रहा है. ठीक है, ग्रिड दे. हाँ, अगर ग्रिड फेल हो गया तो आपके घर में लाइट नहीं आएगी, लेकिन पीवी फेल हो गया क्योंकि हम पीवी लगा रहे हैं ग्रिड के साथ. तो पीवी फेल हो गया तो जब तक आपका आप ठीक करवाइए, एक दिन में करवाइए, 2 दिन में ठीक कराइए, आपके लोड को कोई प्रॉब्लम नहीं होगी. लोड आपका लाइट देता रहेगा, या पंखा चलता रहेगा, या लाइट ट्यूबलाइट चलती रहेगी. हाँ, ग्रिड फेल हो गया तो फिर सोलर आपके इस केस में काम नहीं करेगा क्योंकि सोलर भी बंद हो जाएगा. ठीक है, उस केस में आपको बैटरी लगानी पड़ेगी, मगर मैं पहले ही बता चुका हूँ वो एक बहुत महंगा सौदा है. ठीक है, देन कम द स्टैंड अलोन सिस्टम. स्टैंड अलोन सिस्टम में आपको एक बैटरी लगानी पड़ेगी, और चूंकि बैटरी की कॉस्ट मेंटेनेंस ज्यादा है इसलिए हम इस पर ज्यादा प्रेफर नहीं करते हैं. ठीक है, ये जनरली वहां लगाया जाता है जहां एसेसिबल नहीं है लाइट. जैसे कोई अंदर बिहड़ों में रह रहे हैं, जंगलों में रह रहे हैं, या समुद्र के बीच में रह रहे हैं, तो देयर वी कैन गो फॉर द स्टैंड अलोन सिस्टम. तो लेकिन इसको भी डिजाइन करते वक्त ये ध्यान रखना पड़ता है कि स्पेसिफिक लोड को ही ये रिक्वायरमेंट को कर सकता है. ठीक है, और इस ये फेलियर हो गया तो आपके लोड को कोई पावर नहीं मिलेगी. अब आप जब तक वो ठीक नहीं होगा तब तक आप उसको लोड को यूज नहीं कर सकते. सो दिस आर द सम प्रिंसिपल्स, डिजाइन एंड साइजिंग प्रिंसिपल. लेट अस टॉक अबाउट द ग्रिड कनेक्टेड सिस्टम. ठीक है, ग्रिड सिस्टम की साइज को डिजाइन का क्या मतलब हुआ? डिजाइन करने का मतलब
हो जाएगी, देखना ये 2023 की नंबर 1 चलाने वाली पिक्चर है.
भूमिका,
दीपिका पादुकोण बॉडी सीट पे.
भूमिका प्लीज म्यूट योरसेल्फ.
क्या होता है? दीपिका पादुकोण.
Okay, so the sizing for grid connected system without energy storage involves the following. What is? You have to determine the maximum array power output. Now, once you have designed the maximum array power output, okay, then you have to find out how much area is available to you. Generally, these grid connected systems are installed on rooftop क्योंकि हमारे पास जगह चाहिए. ठीक है, और वैसे भी हिंदुस्तान में पॉपुलेशन इतनी है कि हमारे पास जगह की कमी है. तो एक ही स्थान हमें मिलता है जहां सूर्य की रोशनी भी मिल सके और एरिया वो है हमारा रूफटॉप। ठीक है, अब उसमें कई इनोवेटिव डिजाइन आ गई हैं। एक डिजाइन हमने भी की हमें डिपार्टमेंट में, तो अगर आप डिपार्टमेंट में जिस समय आएंगे तो मैं आपको दिखाऊंगा वो किस प्रकार की इनोवेटिव डिजाइन है। ठीक है, लेकिन अभी फिलहाल हम यही बात करेंगे कि आपने डिसाइड कर दिया कि मैं इतना एरे इतना सोलर लगा सकता हूं, लेकिन आपके पास अवेलेबल ही नहीं है एरिया, तो देन इट इज वेरी डिफिकल्ट फॉर इट। और एरिया भी कौन सा? shadow free area. The area should be shadow free area. ठीक है, then you have to decide how much, what is the efficiency of the PV module used. आपने monocrystalline लिया, PV लिया, monocrystalline लिया तो आपको 20% तक efficiency मिल सकती है, और अगर आपने polycrystalline लिया तो आपको 16 या 17% मिल सकती है। फिर उसके बाद चलो मॉड्यूल आपने अवेलेबल एरिया आपने सेलेक्ट कर लिया, एफिशिएंसी आपने देख ली, फिर आपको इन्वर्टर सेलेक्ट करना है। इन्वर्टर ऐसा प्रकार का करना है उसकी एफिशिएंसी ज्यादा, उसमें अगर लॉसेस हो गए तो फिर आपके बहुत सारा नुकसान हो जाएगा। फिर उसके बाद इन्वर्टर इन्वर्टर का जो आउटपुट है वो एसी होगा, इनपुट डीसी होगा, तो उस डीसी को सप्लाई कौन देगा? आपके ये एरे देंगे। अब इन एरो को कितने कैसे कनेक्ट करना, कैसे सीरीज में करना पैरेलल में कनेक्ट करना, ये भी एक डिजाइन का इशू आएगा। ठीक है, फिर उसके बाद आपके जो आएगा कि ये जो आप एरे मैक्सिमम एरे डिसाइड कर रहे हैं, हालांकि बहुत पहले आना चाहिए था। ठीक है, ये आपको कितना चाहिए? ठीक है, ऐसा नहीं है कि आप मेरे घर पे आपके पास खूब सारी लैंड अवेलेबल है, ठीक है, तो आप कह रहे हैं नहीं साहब मेरे को पूरी लैंड पे ऑक्यूपाई कर दो, और आपने देखा कि आपका ग्रिड तो अलाउड ही नहीं कर रहा है, क्योंकि हर गवर्नमेंट ने अपना एक रूल्स रेगुलेशन बना रखे हैं कि आपका जो ट्रांसफॉर्मर है, मोहल्ले में जो ट्रांसफॉर्मर लगा है, उसके जो राजस्थान में की बात कर रहा हूं, उसके 80% के लोड तक आप अपना ग्रिड कनेक्टेड लगा सकते हैं। यदि आपके मान लो मोहल्ले में 100 केवीए का ट्रांसफॉर्मर लगा हुआ है, तो 100 केवीए का ट्रांसफॉर्मर उसका 80% कितना होगा? नियर अबाउट 80 किलोवाट। इसका मतलब आपके मोहल्ले में टोटल सोलर फोटोवोल्टिक 80 किलोवाट का लग सकता है, एज पर राजस्थान गवर्नमेंट रूल्स एंड रेगुलेशन। ठीक है, कुछ जैसे तमिलनाडु में एरिया में 90% कर रखा है, गुजरात में भी कर रखा है, लेकिन हमारे राजस्थान में 80% है। तो जिस दिन मोहल्ले में ये 80 किलोवाट पूरा हो गया, तो अब वो नया कोई 81 वाला लगाना चाहेगा तो उसको गवर्नमेंट परमिशन नहीं देगी। इसलिए आपको बहुत स्मार्ट वे में बहुत जल्दी इसको लगाना पड़ेगा, क्योंकि जिस दिन मान लो आपके 100 केवीए का लगा हुआ है मोहल्ले में ट्रांसफॉर्मर, और आपने सारे मोहल्ले के सब पड़ोसी वड़ोसी ने सबने लगा दिया, और आपने नहीं लगा पाए, तो फिर 80% पूरा होते गवर्नमेंट आपको मना कर देगी, डिस्कॉम आपको मना कर देगी, हम आपको नए कनेक्शन के लिए परमिशन नहीं दे सकते हैं। तो ये कुछ लिमिटेशंस है। इज इट क्लियर? तो ऐसा नहीं है कि हमारे पास लैंड अवेलेबल है और हम मर्जी आए जितना लगा सकते हैं। ठीक है, आपके अपना लोड भी देखना पड़ेगा, आपका घर का लोड भी देखना पड़ेगा, और आपको ट्रांसफॉर्मर का भी केवीए देखना पड़ेगा कि वो कितने केवीए का है। हाँ, भविष्य में अगर आपके मोहल्ले का केवीए बढ़ता है, 250 होता है, तो फिर आपको अलाउड कर देंगे। लेकिन अगर 100 केवी के और पहले से 80 किलोवाट के प्लांट लग चुके हैं आपके मोहल्ले में, तो शायद 81 किलोवाट या नेक्स्ट किलोवाट आपको नहीं मिलेगा। ठीक है, तो ये कुछ इश्यूज है हम ग्रिड कनेक्टेड सिस्टम की साइज को डिसाइड करते वक्त। अब पहला स्टेप क्या है? पहला स्टेप है किसी भी सिस्टम को डिजाइन करने से पहले, हमारा सोलर ग्रिड कनेक्टेड सोलर पीवी सिस्टम को डिजाइन करने सबसे पहले है कि साइट पे विजिट करना। ठीक है, जैसे सिविल इंजीनियर्स कोई भी मकान बनाने का कोई उनको कॉन्ट्रैक्ट मिलता है, तो वो सबसे पहले क्या करते हैं? दे गो टू द साइट। ओके, तो ऐसे कैसे हमारे इलेक्ट्रिकल इंजीनियर को, ठीक है, या जो भी सोलर इंजीनियर है, ओके, इट कैन बी फ्रॉम एनी ब्रांच, बिकॉज दिस इज आई थिंक सो मल्टी डिसिप्लिनरी ब्रांच, दो इलेक्ट्रिकल कंपोनेंट्स इज मोर बट इट इज अ मल्टी डिसिप्लिनरी ब्रांच। तो आप सबसे पहले साइट पे जाइए, जो कस्टमर या जो आपको बुला रहा है कि भाई मेरे घर पे लगाना है या मेरे इंडस्ट्री में लगाना है, तो आपको साइट पे जाना है। अब साइट पे जाते वक्त क्या करना है साहब? आपको कई चीजें देखनी। सबसे पहले जो सबसे इनिशिएटिव लेना है कि आपको जो ओनर है, जो कस्टमर है आपका, उसको पहले आपको बताना है कि आप पहले तो एनर्जी एफिशिएंट चीजें लें। ठीक है, ये एक बहुत बड़ा एक इंपॉर्टेंट फैक्टर है कि कई बार घरों में हम देखते हैं कि पुरानी ओल्ड ऑब्सलीट, ओके, लो एफिशिएंसी थिंग्स आर बीइंग यूज्ड। ठीक है, जैसे रेफ्रिजरेटर है, अब आजकल गवर्नमेंट इज आल्सो रिकमेंडेड यू गो फॉर स्टार रेटेड रेफ्रिजरेटर। ठीक है, डबल डोर लो या सिंगल डोर लो, अब लोगों के घरों में आज भी पुराने वो लगे हुए हैं, तो दे आर कंज्यूमिंग मोर एंड मोर एनर्जी। पंखे की बात करें तो आज भी जैसे कई कॉलेजों में, कैंपस में और कई घरों में पुराने पंखे लगे हुए हैं 90 वॉट के, इवन 125 वॉट के। ठीक है, शेखावत जी के डिपार्टमेंट में 150 वॉट के पुराने पंखे लगे हुए हैं। शेखावत जी, आई एम करेक्ट? Care. So these are not energy efficient devices. So the first duty of any solar engineer is to suggest the owner that you should replace all your items with energy efficient thing, energy efficient AC, energy efficient cooler, energy efficient TV, energy efficient our refrigerator, energy efficient micro oven. Okay, so that your energy consumption is first of all should be reduced by these energy efficient devices. Okay, this should be the first thing. Okay, uh, uh, even you can go for one such that if somebody is using electric hot water, then you can suggest him that go for solar water heater. Okay, uh, or another solar water heater, either which is by the solar radiations, his thermal energy, or by electrically boosted like this. Okay, similarly, incandescent light bulbs can be replaced by the LED bulbs. Okay, LED tube lights, LED street lights, LED your lamp and all this, because they are consuming less energy, electrical energy. Then the second thing is that while going to the site, you should keep in mind the uh, safety and healthy risk while working on that particular site. Okay, because you have to keep your own body in such a way that no risk is involved with it. Okay, safety precautions have to be taken into account. Okay, then after taking into account all the safety precautions, you have to determine the solar assess for the site. अभी मैं आगे बताऊंगा कि इसको सोलर को एसेस कैसे कर सकते हैं। ठीक है, हम क्या वहां पर सोलर रेडिएशंस आ रही कि नहीं आ रही है, ये सबसे बड़ा चीज है। इज इट क्लियर? और सोलर आ रही है तो कहीं उसमें कोई ऑब्स्टेकल तो नहीं आ रहा है। आपके घर पे छत पे गए, आसपास घर, जैसे शहरों में आसपास घर होते हैं, तो आसपास घरों की शेडो भी आती है। शेडो कितने बजे आती है, ठीक है, कितने देर तक रहती है, सारे पॉइंट्स हमें मार्क करने पड़ेंगे। वी विल ट्राई टू अवॉइड द प्लेसेस, द एरिया ऑन द रूफ टॉप वेयर shadow is coming either in the afternoon or in the morning or whenever it is coming. Okay, so that has to be taken into account. plus हमारे पास सोलर एसेस जो हो रहा है वो कितने घंटे के लिए हो रहा है, that is also important. Okay, तो and then shading effect we have to take into account. ठीक है, फिर हमारे पास आता है कि ओरिएंटेशन। ओरिएंटेशन हम किधर रखें, तो एक थंब रूल है कि हमारे जो मैक्सिमम सोलर रेडिएशंस हैं वो हमें साउथ की डायरेक्शन में मिलते हैं, दोपहर के 12 बजे से लेकर करीब 3 बजे तक, या 11 बजे से लेकर आप मान सकते हैं 11 बजे से 3 घंटे, तो 4 घंटे का जो पीरियड है इसमें हमें मैक्सिमम सोलर रेडिएशन मिलते हैं व्हेन सन इज इन साउथ डायरेक्शन एज पर आवर अर्थ रोटेशन। सो हम रोटेशन वाला सोलर पैनल ना लगा के फिक्स्ड वाला लगाते हैं, और किधर रखते हैं, अगर हम नॉर्दर्न हेमिस्फीयर में है तो वी विल कीप टुवर्ड्स द साउथ एंड, एंड इफ इट इज सदर्न हेमिस्फीयर वी विल कीप टुवर्ड्स द नॉर्थ एंड। ओके, नाउ अब आपने देखा होगा कि ये सोलर पैनल किसी एंगल पर झुके रहते हैं। ठीक है, तो वो एंगल भी डिसाइड करना ये भी सोलर इंजीनियर का काम है, कितने एंगल पर हम तो ऐसा लगता है जैसे कई जिसको नहीं मालूम है उसको लगता है कि कोई ऐसे ही कुछ डिजाइन दिखाने के लिए, समथिंग कुछ नया दिखाने के लिए उसको झुका देते होंगे। नहीं, इट हैज सम साइंटिफिक logic behind it, that why these panels are being tilted, these angles, these panels are being tilted as per the scientific rule. They are tilted at an angle equal to the latitude of that city. ठीक है, तो जिस सिटी का जो लैटिट्यूड है उस पर उसको टिल्ट करना पड़ता है। जैसे उदयपुर का जो लैटिट्यूड है वो 24.68 डिग्री। ओके, सो इट इज बेटर that if you can install your solar panel at an angle of 25 degree, then it will absorb maximum solar radiations when placed in the south direction. If it is installed at 10 degree or 45 degree, then the solar radiation absorbed will be less in comparison when it is tilted at an angle of its latitude. Then you have to calculate the available area. Now available area here means shadow free area. ठीक है, आपको ये देखना पड़ेगा कि आपका शेडो फ्री एरिया कितना है. ठीक है, मैं बार बार इस पे स्ट्रेस कर रहा हूं. यू हैव टू सी हाउ मच शेडो फ्री एरिया इज देयर. ओके, देन वेदर द रूफ इज सुटेबल. अच्छा, ये सबसे बड़ी इंपॉर्टेंट बात है, इसमें सिविल इंजीनियर्स का रोल आएगा. तो आपको सिविल इंजीनियर की भी एक मदद लेनी पड़ेगी. ठीक है, हमारे साथ शेखावत जी हैं. ठीक है, he is very good expert in civil engineering. So you have to take, or you have to understand himself already, that whether this roof is able to sustain the weight of that solar panel or not. ठीक है, सोलर हर पैनल का भी अपना एक वेट होता है 15 से 20 किलो के बीच में. तो ऐसे मान लो आपके 100 पैनल लग रहे हैं, तो टोटल द वेट यू आर पुटिंग ऑन दिस 15 into 100 means 1500 kg weight is put on it. So if it is, if your this panel is very, if your this rooftop is very old or made up of some old material, then it may cause crush in the whole building. So try to avoid such type of building and suggest them that since it is an old building, it is very difficult to install the panel on it. Second more important thing is there that इन ग्रिड कनेक्टेड में एक जो बड़ी इंपॉर्टेंट बात है कि हम फाउंडेशन बनाते हैं. तो फाउंडेशन बनाते वक्त हम क्या करते हैं कि हम छत को थोड़ा बहुत हमें क्रीपिंग करनी पड़ती है. और अगर वो क्रीपिंग प्रॉपर से किसी वाटरप्रूफ मटेरियल से आपने अगर उसको नहीं ढका, वापस उस पर नहीं लेप किया, तो बहुत चांसेस है कि बरसात के दिनों में आपके वाटर लीकेज होगा और वो आपकी छतों में जाएगा, घर के अंदर आएगा और फिर आप परेशान होंगे. इसलिए अगर जो लोग अब नया घर बना रहे हैं, and if they have intention of installing rooftop solar plant, तो वो अभी से ही उसके फाउंडेशन बना दें. क्योंकि कई बार क्या होता है कि हम बाद में बनाते हैं, तो हमारे यहाँ पे इंडिया में थोड़ा बहुत ये है कि the labor want to just do the work in somehow way. They never take into account what will be the consequence of their careless work. So sometimes what happens while creeping, it is not being properly waterproof. Okay, so the water leakage is there during the rainy season, and that may disturb you. So on one hand you are saving electricity, on the other hand you are mentally disturbing yourself due to leakage, and again go for some civil engineer or some civil expert or like this. So this is very important, that whether roof is suitable for mounting the arrow or not. So mechanical strength of the roof is also being taken into account. So for that purpose you have to consult an civil expert, civil engineer expert, who will recommend whether to install the panel on your roof or not. Another thing is how to mount on the roof. Okay, now what happens that sometimes space is limited, and if you install the complete roof, complete these modules on the rooftop, whole thing will be occupied. Now you cannot use roof. So why not we can have a innovative design. Okay, so one such innovative design is that you can install in a form of, install the roof, these panels in the form of shed. ओके, आप शेड के रूप में उसको ले सकते हैं. तो बरसात के दिनों में आप वहां उसके नीचे बैठ भी सकते हैं, आप वहां नीचे बिस्तर लगाकर सो भी सकते हैं. इस प्रकार आपकी छत का सोलर मॉड्यूल भी लग जाएंगे और शेड भी बन जाएगा, और शेड के नीचे आप उसका कुछ ना कुछ इस्तेमाल, गमले लगा सकते हैं, कुछ भी कर सकते हैं. एनीथिंग यू कैन डू इट. सो दैट ऑल्सो बी टेकन इन टू अकाउंट during the site visit. You should suggest to the customer that rather than having a low height module, you go for a higher height shed like structure, so that your this below portion can be used for some other purpose. देन इन्वर्टर लोकेशन, कल ही मैं डिस्कस करा था रात को कि है ना, इन्वर्टर भी ऐसी जगह लगाएं जो वो बरसात में खराब ना हो, पैनल के नीचे ना हो. अभी हमारे एक डिपार्टमेंट में पैनल के नीचे लगा दिया, तो जैसे एक सर्ज आई, ठीक है, उस सर्ज ने आग जैसे ही उगली, तो पैनल के नीचे लगा हुआ था, तो उसने केबल भी जला दी और पैनल को भी जला दिया. ठीक है, तो इन्वर्टर शुड बी इन अ सम रूम which may be at the bottom of the rooftop or may be located on the rooftop only. Okay, so it should be away from water and all this, and should not be below the rooftop like this. Okay, then cabling route. ओके, केबल कितनी लगनी है, इज इट क्लियर. केबल का रूटिंग क्या होगा, ऐसा ना हो कि वो बीच में आए, आपके छत के बीच में जा रही है और बार बार आप छत के ऊपर जा रहे हो, ठोकर खाकर गिर रहे हो. ठीक है, और शॉर्टेस्ट पास्ट होना चाहिए ताकि वोल्टेज ड्रॉप शुड बी मिनिमम, ओके। और आपके लेंथ भी आपको निकालनी पड़ेगी कि ये मैं इन्वर्टर तक ले जाऊंगा, ठीक है, इन्वर्टर के बाद फिर मैं ग्रिड में ले जाऊंगा या ट्रांसफॉर्म पे ले जाऊंगा, या तो मेरा कितनी लेंथ होगी। Then monitoring panels and screens are required and determine a suitable location with the owner. Okay, say how you will monitor the panel. Okay, that also you have to determine it while visiting the site. So these are some important points I am telling you. Just that if you want to install, then you should expect from the engineer that he should look into all this matter, or you himself want to become a solar engineer, then you should take into account all this things into account. So any questions so far? Yes, Professor Shekhawat sir.
Yes, sir. Yes, sir.
Sir, thing is going well.
Sir,
Any question?
भी वालों का बड़ा स्मार्टनेस है कि वो क्या बोलते हैं, फॉलो नहीं करना आपका।
Sir, I am not getting a point. What you are saying? Now, the sir, I am proceeding further. After site visit, I have told you in the site visit one important point. Okay, determine the solar assets for the site. Okay, so definitely you will say, sir, how to assess the solar, how to assess the solar radiations is there. Okay, so because all your calculation depends upon that the amount of the solar energy provided by the sun over a period of day on that particular place. Okay, now this intensity of the solar is being referred technically as a solar insolation. Okay, and it is measured in watt per meter squared. Watt per meter square, as you can see, this is there. Okay, uh, this you can see it. So you have to either determine from some authentic agency. I will tell you the name of the authentic agency, or you can have an instrument called pyranometer. Okay, so when you go for site visits, you require certain instrument also. Okay, and one such instrument is though it is very costly. Okay, but if you want to become a consultant or the or what is solar engineer, then you should have these type of meters with you. Pyranometer is one such instrument where you visit at the 12 o'clock at the noon. Okay, so at the noon we expect that at every site at the noon the sun is at the in the southward direction, and there yes, Dr. Himani is writing NASA and all this. Yes, they. I will tell you in my this this slide only that NASA is also providing, NRAL is also providing. But if you don't have the pyranometer, then you can go for some other sites, websites who already have all the data collection. And Dr. Himani has used that data also in his thesis. Okay, very good. Okay, so and its unit is watt per meter square. Okay, so you must know of each and every location where you want to go. So if you are installing in Udaipur, then you should know what is the solar insolation of the Udaipur. The target value is always 100 watt meter per meter square. This is the standard value. Okay, and this typical value is obtained at 12 noon. Okay, when the sun is at the highest location in the sky in the south direction. Okay, so another thing is that we require the peak sun hours. Peak sun hours. Okay, so what is this peak sun hours? These peak sun hours, PSH. Sometimes in the books you will write, you find PSH. So this peak sun hour is equal to number of hours. The insolation value is at 1000 watt per meter square. So up to how many hours this 1000 watt per meter square remains? So that will become peak sun hour. That is very important, and that you have to find out. Okay, and for example, if any place which has a peak sun hours, that is the solar insolation of 1000 watt per meter square is continued for 3.5 hours, then it's this the so called the peak sun hours will be 3.5 multiplied by 1000. Okay, so it will become watt hour per meter square. So this reading is required. This reading is required. Watt hour per meter square is required. You multiply 1000 by 3.5 and then you also divide by 1000. You will get the kilowatt hour per meter square. So for this particular location where the solar installation of 1000 watt meter remains for 3.5 hours, it will be 3.5 kilowatt hour per meter square. Okay, so this data either you measure through pyranometer or you have an website provided by NASA. Okay, so this is the eosvab.lat.nasa.gov is there, and even this data is also provided by National Renewable Energy Laboratory. However, the one thing is that the NASA data has in some instances has higher irradiation figures data recorded by ground collection data in some countries. But if though no data available, then this data can be used, or you should have a pyranometer. Okay. And I have already told you the unit became now kilowatt hour per meter square. So kilowatt hour is the basically the unit of energy, and energy is nothing but power multiplied by time. Okay, so we are interested in how much energy is being delivered by solar. Okay, in 1 hour. Okay, so that became your solar irradiation or solar insolation. Okay, and from NASA website you can obtain, or from National Renewable Energy Laboratory www.nrel.gov you can obtain it. Okay, you have to make a search for it, for your location, for your latitude. You have to just put your location, latitude of your city. For example, Udaipur has a latitude of 24.68, which is approximately 25. You just put it. It will give you, oh, this is the solar insolation of your city. Okay, so very clear that how a solar engineer assess the solar data, the solar insolation. Now, once you have assessed it, now you have to arrive at that. Now you have to go for some calculation. Okay, one calculation is that how much is the average daily use of electricity is there. Now you say, sir, how to find out? So if you ask a layman, how much energy I am using daily, so what he will do, sir, I have this much appliances, I have a tube light of 20 watt, I have this a fan of 50 watt. Then on Monday I am consuming this, I am using this fan for 6 years on 6 hours, and for Tuesday I am for 5 hours. And in this you go for calculation for the whole year, and the whole year will be consumed. But we have a very good trick. What is there? That those who are using electrical energy in their home or residence or industry or institute, then they might have the previous year's electricity bill. Okay, so in some states, even some cities of our state, for example Rajasthan state, you will find that we are in Udaipur, we are getting 2 month bill. Okay, but in some cities like Jodhpur, 1 month bill, every month bill is coming. So you have to collect for a 12-month previous year bills, electricity bills. In electricity bills, you will note down that some units are being written. Okay, 200 units. This 200 units are nothing but, when I say 200 units, it means 200 kilowatt hour of energy has been consumed by you either in month or in a 2 months. Okay, so you collect for those who are getting per month basis these bills. They collect for 12 months. January, February, March, April, May, June, July, August, September, October, November, December. And those who are getting bi-monthly bill, then they should collect for January, February, March. It means 6 bills. So for year, those who are getting monthly, they have to collect 12 bills, and those who are getting bi-monthly, they have to get 6 bills. Now you add all these units of all these bills of this complete 1 year, and then divided by 365. Divided by 365, you will get an average daily use. You will get an average daily use. So this is the first step. The first step while designing any how much solar power you have to install. Just calculate the how much annual energy usage is there, and then divide it by 365. You will get an average daily use. Okay, so Dr. Abrar Ahmad has joined with us. Okay, so I will take a few minutes, 5 to 10 minutes more, then we will switch over. We will have a 2-3 minutes break, and Dr. Abrar will continue. Dr. Abrar, welcome.
Thank you, sir. Thank you.
Okay, so Now, say, let us understand with the example. Suppose a residence has an annual energy usage of 6,000 kilowatt hour. So this we have obtained by adding all the units of previous year bills, and now we will divide it with that 365. So we will get an average consumption. Now, this average consumption, the unit is kilowatt hour. This is energy. Okay, this is energy. Now, this energy we want that it is to be supplied by the solar system. So what is the next step? Let us say, now I have divided by 6,000 by 365. I get 19.2 kilowatt hour. Okay. So now this 19.2 kilowatt hour is the daily average consumption. Okay. Now this has to be met with the solar PV system. But still things are not, it doesn't mean that I just install a solar panel of 19.2. No. This is energy. So I have to convert into power. So again, I have to find out peaks and hours for that city. Okay. Now I will divide this 19.2 kilowatt hour, that is the daily average consumption, by peaks and hours. So again, peaks and hours you can find out from the geographic location of that particular city. Okay, divide by that, you will get this is the amount of the power which is to be supplied by the solar. But still many things are to be taken into account. So what I have done, 19.2 is divided by 6.5. Let's say this particular example we are taking into account have an 6.5 peaks and hours. So how much I will get? I will get certain values. Okay, I will tell you. Then what happens? After getting this value, I have to divide it by some losses. Some losses in order to take into account the derating effects. Okay, what are derating effects? I will tell you later on. So I have divided by temperature losses 0.88. Okay, I will get certain value. Then I have to divide it by the inverter efficiency. So when I divide it by inverter efficiency, this is the value which I will get. It is the input of the inverter. This is the input of the inverter. Now this input is to be provided by the solar array, the solar which I am going to build. But still we have to take into account another derating factor, and generally it is being taken 0.77. What is this general derating factor? What happens that the solar power being generated when being fed to the inverter, in between there are so many losses are there. जो सोलर जनरेट करता है और इन्वर्टर को देता है एज ए डीसी, उसके बीच में कई प्रकार के लॉस होते हैं. वो लॉस कैसे हो सकते हैं? डर्ट लॉस हो गया, आपके केबल के ड्रॉप के लॉस हो गया, ठीक है, मॉड्यूल की वोल्टेज ड्रॉप हो गया. वो सारे लॉसेस हम कंबाइन करके एक 0.77 वैल्यू पे आगे, हालांकि ये हम 0.72 तक ले सकते हैं. आगे मैं आपको टेबल बताऊंगा, उसमें आप बताए 0.72 तक ले सकते हैं. ठीक है, तो जैसे एग्जांपल समझाने के लिए मैंने 0.74 लिया, तो इससे हम अराइव किए 4.52 kilowatt. So this much of the solar array, this much is the maximum capacity of the solar array we have to install for this particular example. तो पहले हमने डेली कंजप्शन निकाला, उसको हमने उस सिटी के या उस लोकेशन पे कितने पीक आवर्स आता है उससे डिवाइड किया, फिर टेम्परेचर लॉसेस से हमने डिवाइड किया, इन्वर्टर की एफिशिएंसी से डिवाइड किया, फिर जनरल डिरेक्टर फैक्टर से डिवाइड किया, और लास्ट में जो हमें वैल्यू आई वो हमारा क्या है? द रेटिंग ऑफ द पीवी एरे व्हिच वी हैव टू इंस्टॉल ऑन दैट पर्टिकुलर पॉइंट. ओके, नाउ दिस इज द पीवी मॉड्यूल. When we say this is a particular kilowatt, say 250 watt or 300 watt, then this is the maximum. This is the maximum power output. Now what happens if I say any person, that you have a 300 watt a solar module, so how much energy it will generate? So what he will do, I have a 300 watt, I multiply by my, suppose by peaks and hour is 6, I multiply by 300 into 6, I will get 1800 kilowatt hour of energy. No, it is theoretically only correct, because in reality, okay, this 300 watt may decrease or may increase. Okay, it may sometimes at the 12 o'clock it may be 300, at 12 at 1 o'clock it may be 280, at 2 o'clock it may be 250, or like this way. So theoretically we say we get 1800 kilowatt hour, but it is not practically correct. So because there are many inefficiencies are there in the system, so we have to take into account that inefficiencies also, and that inefficiencies are called derating factors. So that is very important. मैंने आपको कुछ डी रेटिंग फैक्टर्स पहले ही बताए थे, अब आप मैं डिस्कस करूंगा डी रेटिंग फैक्टर्स क्या होते हैं. ठीक है, हर इक्विपमेंट, हर डिवाइस जो सोलर फोटोवोल्टिक सिस्टम में लग रहा है उसके साथ एक डी रेटिंग फैक्टर है. आपका मॉड्यूल है, मॉड्यूल का जो पावर है उसमें डी रेटिंग फैक्टर है. अब मॉड्यूल कैसे चेंज होगा कि मॉड्यूल टेम्परेचर के साथ उसका चेंज हो सकता है. ये जो मॉड्यूल बने हैं आपके, जो 250 वॉट के या 300 वॉट के या 400 वॉट के, इवन आजकल 500 वॉट के, ये सभी एसटीसी पर बने हुए हैं. STC में स्टैंडर्ड टेम्परेचर कंडीशन, दैट इज 25 डिग्री सेंटीग्रेड. So if temperature increases beyond 25 degrees centigrade, okay, their voltage will reduce, and due to voltage reduce, the power output will also reduce. So generally we take into account the derate value of 0.95. However, and the acceptable values are also there. Now sometimes what happens, if temperature is below 25 degree, then the voltage may rise. Okay, so you may get a value greater than 1. So this is the acceptable value, but in general we take 0.95 value. दूसरा, इन्वर्टर पे भी है. आपके इन्वर्टर, आपको इनपुट आपको दिया, आपको आउटपुट से कम मिलेगा, उसकी वो एफिशिएंसी है. ठीक है, तो वो 0.96 लेते हैं, जैसे मैंने डिवाइड किया था उस एग्जांपल में. फिर आपके मॉड्यूल मिसमैच. कई बार क्या होता है कि हमें पर्टिकुलर मॉड्यूल नहीं मिल रहा, तो हम क्या करते हैं कि एक 250 के साथ सीरीज में 300 कनेक्ट कर दिया, या पैरेलल में उसके साथ कनेक्ट कर दिया, तो यहाँ ये मिसमैचिंग हो गया. इज इट क्लियर? तो हालांकि ये होना नहीं चाहिए, लेकिन फिर भी हम ये एक्सपेक्ट नहीं करते कि एक जैसे ही सारे मॉड्यूल बन जाएंगे. ठीक है, कई बार हम 250 और 250 का कहने को लगा हुआ है, लेकिन उसमें भी कुछ मिसमैचिंग फैक्टर होता है, तो वो भी हम 0.98 लेते. दीज आर ऑल इनएफिशिएंसीज. Diode connection, but generally their drop is very less, so we generally take 0.995. Then DC cables are being used to supply from PV array to inverter. They also have a derating factor of 0.98. AC wiring is being used from inverter output to the grid. That factor is 0.99. Then dirt. Soiling means dirt on the panels. We expect that everything will be clean, but in general what happens, because they are present in the open atmosphere, so dirtness will be there. That will take into account derating factor 0.95. System downtime. Okay, sometimes for cleaning purpose we may shut the our system, so that you also, but it is not shut for more than half an hour, so that we also take into 0.98. Then shading effect is generally there. We expect that we should avoid the shaded area, but sometimes the things are not in our hand, so some building is constructed near it, or some tree grows, so that in fact should not be there, but if happens, then we also take into account a derating value of 0.90. And overall from DC to AC, the derating factor is being taken up to highest 0.722. Okay, so these all derating factors are being taken into account, and if I will multiply, and what happens while making calculation, we multiply all these derating values just like this, 0.9, 0.96, 0.98, and ultimately it comes out to be 0.7222. So the maximum allowable derating value is 0.722. Okay, below this it is not acceptable. It means your system is not working properly, and you have to suffer the losses incurred due to this. Okay, so let us take into example. Okay, home is consuming 4000 kilowatt per year. Average peaks and hours for south facing array is 6.5, and overall system efficiency factor is 66%. Then we have to calculate the array size needed for it. Okay, so what we'll do, as I've already told you, we will calculate the energy consumption per day. So what I will do, that I will divide by 365, I will get to 10.96 kilowatt hour. Now peak sun hour is given 6.5, so I will divide by 6.5, I will get the power consumption per day. So it comes out to be how much? 1.69. Okay, this is 1.69. Now everything has been multiplied. The overall derating factor has been given to you, and that is 0.66. So I will divide by 1.669 by 0.66, and I will get 2.55 kilowatt hour. Okay, so this is the solar array I required on my that residence. Okay, that to be installed on that given residential place. Okay, then how to select the modules. Okay, now while selecting the modules, so once you have decided, oh, I have to select, I have to develop an solar photovoltaic system of 3 kilowatt or 5 kilowatt or 10 kilowatt, then I have to select the modules. Now in the modules in the market, you have from very tiny to very large modules. You have a 20 watt also, you have a 10 watt also, 50 watt, 150 watt, 200 watt, 300 watt, and nowadays the things is that 500 watt module is also available. So which you will suggest? So I have to make a 2 kilowatt system. So you will take 20 watt 100 modules or 500 watt 4 modules, which will be more economical. 500 watt 4 modules will be more economical from all respect, rather than taking 20 watt 100 modules, because you have to place it over a large area. So large area will be covered, plus the mismatching factor will also increase. So all these factors made that you generally go for a higher size available in the market. So nowadays 500 watt is available. Okay, so you for 200 kilowatt you just go for 4 modules only, make it in the shaded form in at upper height, and definitely you will have a shed also, and you have a solar power plant also. Okay, so I have just highlighted one such module specification. Okay, so it is generally given 240 watt. So it is the peak value at a STC condition, standard temperature condition, and maximum power voltage, that is the voltage when we have a maximum power, it is given 29.86. So these are the ratings are being specified in the modules. So जो भी मॉड्यूल होता है ना उसके साथ ये सब शो किया हुआ होता है. उसी प्रकार करंट कितना है उस मैक्सिमम पावर पे, तो 8.109. फिर मैंने कल बताया था, परसों बताया था आपको कि ओपन सर्किट वोल्टेज क्या होता है, तो ये भी मेंशन किया होता है 36.45. ये सारी चीजें हमारे इन्वर्टर के डिजाइन में काम आती है. शॉर्ट सर्किट करंट 8.59 एम्पियर. फिर एक टेम्परेचर कोफिशिएंट होता है कि यदि टेम्परेचर बदलता है, देखिए टेम्परेचर जैसे आपके ये सारी सब जो मॉड्यूल है डिजाइन है ये 25 डिग्री पर है. अब आपका मान लो गर्मियों में टेम्परेचर आजकल उदयपुर में 45 जा रहा है, डेजर्ट एरिया लेंगे जैसलमेर बाड़मेर में तो वहां तो 50 डिग्री जा रहा है. तो डेफिनेटली द पावर रेटिंग विल चेंज. दिस 240 will no at 12 or noon will not give 240 watt. It will give a decreasing value. I have already told you that temperatures have a negative effect. How to calculate it? With the help of this temperature coefficient. Okay, similarly in the cold season like in America and all this California, okay, the temperature goes below -degree. So there also what will happen, the voltage level will increase, and therefore we will may have a higher output. Okay, sun is coming in the -degree centigrade, then we may have a higher output, so it can damage our inverter. So we have to take into account this also. So after selection of the array, okay, selection of the solar array, we have to select the inverter sizing also. Okay, so in inverter what happens, what is the input of the inverter? Input of the inverter will be always solar DC, the DC generated by solar system, and output will be always AC. That is what the function of inverter is. Inverter का function यही है कि DC को AC में कन्वर्ट करना, क्योंकि हमारे सारे हाउस होल्ड डिवाइसेस AC पे चल रहे हैं. और इसका मतलब ये हुआ कि अगर हम घर की बात करें तो घर पे हमारा 230 वोल्ट आता है. ठीक है, 230 वोल्ट आता है, तो हमारा जो आउटपुट AC का होगा वो 230 वोल्ट होगा, लेकिन जो इसका इनपुट वोल्टेज होगा, ठीक है, वो 230 वोल्ट नहीं होगा. वो डिपेंड करेगा आपके जो पीवी एरे है. ठीक है, how much array, what is the string size of that array. Now how to form that string size? Okay, what is the minimum number of module in series, what is the maximum number of modules in series, and how many source or circuit can be wired in parallel. तो यहाँ पे रीअरेंजमेंट आ गया कि हम मॉड्यूल्स लें 2.5 किलोवाट, मतलब आपने मान लो आपका आया 2 किलोवाट, सपोज आपका आया कि आपको 2 किलोवाट का पावर प्लांट इंस्टॉल्ड करना है. ठीक है, पीक वैल्यू. अब आपने कहा साहब मैं 500 के 4 ले लूंगा. ठीक है, तो ये आपका 2 किलोवाट का बन जाएगा. लेकिन अब इन 500 को किस में कनेक्ट करना है, सीरीज में कनेक्ट करूं, पैरेलल में कनेक्ट करूं, वो डिसाइड होगा हमारे इन्वर्टर के वोल्टेज के अकॉर्डिंग। इज इट क्लियर कि इन्वर्टर कितना सस्टेन कर लेता। अब इन्वर्टर का आउटपुट हमेशा 230 वोल्ट होगा सिंगल फेज सिस्टम के लिए, मगर जो इनपुट होता है वो इट कैन वेरी फ्रॉम 232 from 200 to 600 volt. Okay, so you have to look into the what is the module specification given. Okay, module जो लिया आपने 500 वोल्ट, इसका ओपन सर्किट वोल्टेज इसका वोल्टेज कितना लेवल है और इसका टेम्परेचर कोफिशिएंट क्या है, ठीक है, उसके अकॉर्डिंग हम इसका वोल्टेज लेवल निकालेंगे इन्वर्टर का। लेकिन अब जैसे मान लो आपने 2 किलोवाट का आपने सोलर पाउंड लिया, तो इन्वर्टर की पावर रेटिंग कितनी होगी? इट विल बी आइदर 2 kVA और यू कैन गो फॉर हायर रेटिंग 2.5 kVA। इज इट क्लियर? दिस इज सो जैसे अभी हमारे केस में ये 4.52 निकला था, अगर आप देखेंगे पुराना, ठीक है, तो हमारा ये जो निकला था ये मिनट, ये देखिए जो हमने कैलकुलेशन की थी ना, तो उसमें हमारा ये निकला था 4.52। तो अब आप क्या करेंगे, आपका सोलर एरे 4.52 का है, तो आप कितने केवीए का इन्वर्टर लेंगे? आपको 5 केवीए का इन्वर्टर लेना पड़ेगा, हायर देन दी सोलर एरे रेटिंग। ठीक है, आप 5 का लेंगे, आप 4.5 का लेंगे तो आप कभी ट्रबल में आ सकते हैं। इज इट क्लियर? सो इट इज बेटर गो फॉर हायर वैल्यू। 5 केवीए इज अवेलेबल इन द मार्केट, यू गो फॉर, सपोज ये होता 5.5, देन यू गो फॉर 6 केवीए। Okay, like this way you have to go for some higher rating than the actual rating of this. Okay,
सर दवे सर एक क्वेश्चन था।
हाँ बोलिए सर।
अरे सर जैसे कि अपना 500 वाट का आपने लिया वोल्टेज का, 500 वाट का, तो उसका वोल्टेज तो 36 ही होता है ना, तो 36 into 4 करीब
नहीं
करीब
वो
मतलब
आपने 36 ले लिया, लेकिन आपको 36 into 4 किया ना आपने, तो अब आपको इन्वर्टर के वोल्टेज भी देख, मैं वो
इनपुट वोल्टेज तो
कैलकुलेशन आगे आ रही है सर, वो कैलकुलेशन आगे आ रही है सर।
अच्छा ठीक है।
वो जैसे अब आपको क्या करना है कि आपको उस मॉड्यूल का वोल्टेज भी देखना है, तो उसके लिए आपको उस जगह का लोएस्ट टेम्परेचर कितना है और हाईएस्ट टेम्परेचर कितना है ये देखना है। ठीक है, तो जैसे हमने हमने किसी एक लोकेशन का लिया, उसमें लोवेस्ट टेम्परेचर -9 डिग्री जाता है। जैसे आपके चुरू उरू जो प्लेसेस है वहां पर 3 डिग्री, -3 या 4 भी जाता है सर। ठीक है, और कई बार वहां गर्मियां भी बड़ी खतरनाक होती है, तो टेम्परेचर 47 भी जाता है। तो ये हमने -डिग्री एक्सट्रीम लिया है कि इतना लोअर उस पर जा सकता है सर्दियों में, और हाईएस्ट गर्मियों में इतना जा सकता है। तो अब हम क्या करेंगे सर कि हम उसका एक करेक्टेड वोल्टेज निकालेंगे अकॉर्डिंग टू द टेम्परेचर कोफिशिएंट जो हर मॉड्यूल के साथ एसोसिएट होता है। ठीक है, और उस टेम्परेचर के कोफिशिएंट के अकॉर्डिंग हम ये निकालेंगे हम कितने मॉड्यूल यूज कर सकते हैं। ठीक है, तो अब जैसे आपने ये हमारा वीओसी मैक्सिमम दिया हुआ होता है। ठीक है, ये हमारा कितना जा सकता है, तो ओपन सर्किट वोल्टेज दिया हुआ है आपके, और ये हमारा फॉर्मूला है 1 + T min - TSTC। TSTC हमारा जो मॉड्यूल के साथ वो जो टेम्परेचर होता है वो कितना था 25 डिग्री, और मिनिमम कितना गया आपने फाइंड आउट किया -9 डिग्री। ठीक है, और टेम्परेचर कोफिशिएंट मॉड्यूल के साथ एसोसिएट होता है, वो हमने मल्टीप्लाई किया, तो हमारा ये आया कि सर्दियों के दिनों में अगर टेम्परेचर बिलो गया और सोलर इंसुलेशन आ रहा है, तो उसका वोल्टेज 40.52 वोल्ट जा सकता है। जबकि हमें दिया हुआ कितना था सर, ओपन सर्किट वोल्टेज मैक्सिमम 36.5 है, अभी जा कितना सकता है 40 मीन्स 11% हायर देन द मॉड्यूल वोल्टेज। तो अब हमारे पास सर क्या है कि इन्वर्टर का इनपुट वोल्टेज मान लो 450 वोल्ट दिया हुआ है। ठीक है, कि 450 वोल्ट है। ठीक है,
Dave, I have a question.
यस सर।
In this, we are calculating the open circuit voltage maximum by using the temperature minimum and TSTC. So the temperature T minimum or T maximum, it should be the module temperature or ambient temperature.
No sir, actually these module temperature are designed for STC. Whatever you purchase in the market, the module, they are always designed for STC, standard temperature condition, that is 25 degrees centigrade. Okay, and these two temperature -9, and these are the extreme temperatures of that location.
No, these are the ambient temperatures.
No, ambient not, so these are the extreme temperature. For example,
Extreme ambient temperatures. So suppose.
Extreme ambient temperature, yes sir.
Okay. Suppose on 47-degree ambient temperature, the module temperature may go to the 75-80 degree.
Yeah, definitely, sir. It will go because of the current flowing and also the solar insolation. Both will combinedly. But all these are being sustainable up to 85 degrees centigrade.
Okay, so here when we are calculating the open circuit maximum voltage, we'll use that 80 degree or only 47?
No, only 47, sir. Because because the most of the things will get dissipated in the form of heat, sir. So it will be affected by the voltage. Silicon will be affected by the voltage. It is being developed due to the this ambient temperature.
Okay, in this calculation we'll use the ambient temperature.
Yeah, ambient temperatures. Yes, the maximum ambient temperature or minimum ambient temperature. So here I have taken -9, so I have used -9 degrees centigrade. So accordingly, you can see that during the cold season, generally misnomer is that during the very high summer season, when temperature is very high, the power will go high. But this is not the case. The power will reduce. While in the cold season, if solar insolation you are getting good, then the voltage may increase and therefore power may increase, sir. So here you are getting a voltage higher than this. So if I divide the inverter voltage, input voltage by this 40.5, then maximum I can choose the 11 modules I can choose it. Similarly, another calculation will be for the this so-called the maximum temperature. So this is the formula being used. Okay, VMP into 1 plus T add plus T max minus TST into T. This is being associated with module. So when I will substitute all these values, okay, what I will get a minimum value of voltage 22.71 volt. Now this also be taken into account, but otherwise sometimes the inverter will not pick up. Okay, so again I will divide by the inverter minimum voltage. So I will get the maximum I can connect 10 modules with this. So on one side I got 11 modules, on one side I get 10 modules. So a compromise has to be made that how many modules I can choose. One the important point is that whenever you go for inverter size, okay, you always go for the higher rating. Okay, for example, in our case we have gotten solar array of 4.52 kilowatt. So it is better to go for 5 kilowatt rather than 4.5 or even 4 lower. Don't go for lower size. Okay, and the already we have calculated these two values through the temperature coefficient. And one important thing, and I will share one document also with you, that every device which are being used has been in our solar PV system has been standardized according to IEC standards or BIS standard. So for inverter, these are some standards: IEC 61683 or IEC 6183, IES 162221. So I will share that document with you, okay, in which everything BIS standard is being written. For example, in solar module, the PV output can vary by plus minus 3%. So that has to be mentioned by the manufacturer. Previously it was plus minus 5%, but now Government of India has changed it. Now it is only plus minus 3%. Okay, so all standards have been written. So while purchasing these type of modules, you should take into account all these things. Now, so you have got how much arrow you have to install, how much value of inverter you have to install. Then you have to keep in mind as an engineer the protection system also. Okay, this is very important, and this may cause the fatal accident if it is not been taken into account. First of all the panels, all the inverters which are being used in the system should be earth. So earthing strips of GI pipes are being used, and you should also maintain the earth resistance with the help by measuring the earth resistivity with the help of the earth measuring instrument, and it should be less than 5 ohm. In fact, the ideal is between less than 1 ohm, but 1 to 5 ohm is just, we can say, good thing. And if it is greater than 5 to 10, then a maintenance is required for your earthing system. And if it is greater than 10 ohm, then it is better not to create any earthing system nearby that area. So it should be less than 1 ohm in ideal case, practical case 1 to 5 ohm, and maintenance is desired where it is between 5 to 10 ohm. Then surge protection system. This is very important, And recently it has caused one such incident in our college also, that sometimes these surge are nothing, these are the voltage impulses of very millisecond. Okay, if they enter into your system either through grid or what happen, or to any media, okay, they will may destroy the whole system. So SPD, this short form is called surge protection device. SPDs are being installed at the AC output end, okay, so that if any type of surges from the grid comes, then the SPD will break and it will save your solar PV system. The third and the most important is the lightning protection system. Okay, LA lightning arrestor are to be provided because these silicons are very much attractive toward the lightning surges. Okay, so many incidents has happened in the absence of the LA system. So lightning protection system should be provided on the diagonal ends of the complete solar system. So because the cost is very less, it is approximately less than 2000 rupees the costing of LA. So it is always recommended that you should put on the diagonal ends of the solar PV system on the rooftop, so that your whole protection system can be saved in case of some lightning surges arises. And moreover, metering system is to be provided, and this is compulsory from discoms. Two types of meters are being provided. One is called net meter. Now your residential energy meter will be replaced by a net meter, where there will be accounting of that how much you are taking from the grid, how much you are taking from the grid. Okay, and how much you are consuming. For that purpose you require not only net meter, but you also require a generation meter, which in technical language, technical people used to speak a solar meter. Okay, this is can be separately also be connected, and some companies also provide on the inverter side also. So companies like Delta company, they provide on the inverter also, and these vendors, they also provide in the form of separate also by connecting CT and PT to it. So this is all about the complete system, that suppose you want to install a system, a grid connected system at your home or your institute, then what factors you have to take into account and how to design it. And today we have got one more news, that our college is installing another 40 kilowatt of solar photovoltaic plant in one of our buildings, and the work has been assigned to me only. Okay, so very soon we have a 40 kilowatt another plant, which will be added to our existing 445 kilowatt plant. Okay, so that's all for today. I have taken too much time. Dr. Abrar Ahmad is waiting for me. So now I directly, so if any question, we can take 1 or 2 minutes. Any questions, sir, please? So meanwhile, I will share that draft also developed by the government of India, that what things are to be taken into account, all the standards while installing the solar PV system on any rooftop. So if no question, then thank you to all for bearing patient and listening to me and sharing your valuable golden time with me. Now I will invite Dr. Abrar Ahmad. Dr. Abrar Ahmad is a well experienced not only in accommodation but also in field engineer. Okay, he has worked over so many projects. At present he is deputy manager in Genesis Private Limited. Okay, and he is working in the research and development wing only, and he has worked on not only power electronics, but he has worked in robotics also, and also in solar photovoltaic system and in electrical vehicle system also. So he is an expert. He did his PhD from Mahana Pratap University of Agriculture and Technology with lot of research papers. He has developed some innovative things also during his field experience, and today it is really a proud moment that he is with us. So I welcome Dr. Abrar Ahmad. Dr. Abrar Ahmad, please, you can start your lecture. I welcome you.
Thank you so much for your kind words, sir.
Mm.
It's a really pleasure for me to deliver a lecture in the FDP organized by you in the Hybrid ATAL Faculty Development Program on the advances in solar photovoltaic and its design for the e-vehicles. And the topic is given me to discuss the fundamental of electrical vehicles. So As sir already told you about my previous experiences and my exposures, so I will be covering the fundamental of electrical vehicles. So let me share the screen. I hope my audio is audible to all.
Yeah, Dr. Abrar, your audio is audible and it is clear, and your screen is also visible to us.
Okay, let me just full screen it. Okay, screen is visible.
Yes, screen is visible and voice is also clear.
Okay, okay. Give me 1 minute. So let's have a look at the content I'm going to cover in this lecture. So I will just break out some myth about the electrical vehicles and let you know some difference about the different electrical vehicles. As of now, we already know that that electrical vehicle, but we do not have the exposure that what different kinds of electrical vehicles are available, and what are the who is the OEMs in the India, or who are the leading manufacturer in the EV market in the world, and also in as well as in India perspective. So I will first discuss the importance of electrical vehicles. Then I will give you the benefits of electrical vehicles, and then we see the architecture of EV and the component, which are different component from which the EV is made, and types of electrical vehicles as I just discussed, and just busting some common electrical vehicle myths and India EV mission and plan. Basically, in this section, I will discuss the what the government of India has planned, and what are the different schemes currently running for just promoting the use of electrical vehicles, and switch to the electrical vehicle from the internal combustion engine type vehicles. And I will finally conclude with some EV sector key achievement under the different schemes. So let's see why we need the electrical vehicle, or why we need to switch to the
सर
electrical
एक
vehicle.
बार ये आपका स्लाइड मेरे को लगता है कि स्पीकर नोट दिख रहा है और वो नहीं दिख रहा मैन पे। स्लाइड जो है ना सर, स्लाइड नहीं दिख रही है बड़ी, स्लाइड वाले पे क्लिक करना पड़ेगा शायद कुछ।
Is it visible, sir? Can
यस सर,
anybody
यस
else
सर।
can confirm me?
Yes, sir. Yes, sir.
So basically, as you all know that day by day, the
Sir,
every company
sir,
is
one
producing
request.
a different.
Sir, one
Yes,
request before.
yes.
Sir, it is humbly request you. Please, sir. Sir, I want to know about energy density concept before we discuss about electrical vehicle technology. Energy
Energy density.
density. Energy
Energy density.
density like that battery, diesel, yeah, some other fuels. Energy density concepts.
It is basically out of scope of this presentation. Basically, the topic you are talking about itself is a very vast topic to discuss here.
Okay.
So I will take the question end of the session. Just let me just first present the all the slides, and in the end of the session we will take the questions. So I was talking about that the importance of the electrical vehicle, that why we need to switch to the electrical vehicle. So the automotive industry has become one of the most important worldwide. As you all know, we have different segments of vehicles. For the if I talk about the middle class level or business class level, or we have the luxurious luxury cars. So the industry is growing is very fast, but the technical elements that being introduced on the vehicle towards the improvement of driving side or comfort side of a passenger, or for the pedestrian safety. As you all know, that Mahindra have introduced the XUV 700 recently, and most of you all know about the safety features that provides in the vehicles and with the safety ratings, and as well as also provide the self-driving system and also provide the ADAS system, which is basically a safety system for the pedestrian safety. And however, it has led to the dramatic increase in the air pollution because these are all diesel or petrol engines, so they are polluting our environment and releasing the harmful gases and like nitrogen oxide, carbon monoxide, sulfur dioxide, that's all. So the authorities of most development countries are encouraging, this is the main reason to switch to the electrical vehicle, because we need to make the environment sustainable for us. So if we are going to keep using the diesel and petrol engines and they are emitting the harmful gases and particles in our environment and polluting our environment, then the greenhouse effect and the environment get polluted. So to reduce this and make the environment sustainable, so different developing country promoting to use the electrical vehicles to avoid the concentration of the air pollutant, carbon dioxide as well as other greenhouse gases. So more specifically, they promote sustainable and efficient mobility through different initiatives. Our government has also initiated several programs to promote the use of electrical vehicles. As of now, everyone knows that at what boom level the each company is working on the electrical vehicles. Either I will talk about the two-wheeler or four-wheeler manufacturer. So to promote the use of EV, government providing the subsidies, providing the public parking facility for the charging stations, providing the charging infrastructure and tax benefits, and lots of things are provided by the government just to promote the use of EV. So let's see some benefits of using the electrical vehicles. First of all, I will discuss the lower running cost. So the running cost, if we talk about the overall cost, that is including the uh, producing the battery as well as the whole life cost, if I consider with the IC engine, then the running cost of electrical vehicle is much lower than an equivalent petrol or diesel vehicle. The electrical vehicle use electricity to charge their batteries instead of using fossil fuel like petrol or diesel. And electrical vehicle, if I talk about the efficiency, they are more efficient compared to the petrol or diesel engine. Next is the low maintenance cost. As you all know that the electrical vehicle does not have the mechanical system like engine, internal combustion engine, it does not have. In internal combustion engine, we have different mechanical parts, drivetrains and valve and chambers, oil tanks and everything. So this electrical vehicle does not have that kind of parts. So the maintenance cost become low, and the servicing requirement for the electrical vehicle are lesser than the conventional petrol or diesel engine. So therefore the yearly cost of running an electrical vehicle is significantly low. Also, I give you the example. I own the two electrical thing, one which is a bicycle and another one is a two-wheeler. Since last 1 year, I'm running from the last 1 year. I have not put as an, if I talk about as in maintenance, I have never put anything in it. I'm just charging it and running it. I have zero maintenance cost for my last year. Okay. Now let us see the next. So zero tailpipe emission, as we do not have the internal combustion engine. So the emission from that vehicle is become zero. So driving an electrical vehicle can help you to reduce your carbon footprint because there will be zero tailpipe emission. and you can reduce the environmental impact of the charging your vehicle further by choosing renewable energy options for home electricity. You will say that the electrical vehicle we are charging, the electricity we are getting from the state discoms, that is produced from the combustion of the coal and everything. But the cost, if we compare to the diesel or petrol, then it is low. As well as if we talk about the, if we replace these, let's suppose we are consuming from the discom, and now if I replace this input which is I'm using to charge my electrical vehicle. If sir, already last 2 days, you are, and the topic of this FDP is also the solar photovoltaic. So solar photovoltaic we can use to charge our electrical vehicle. There are some constants that I will discuss tomorrow lecture, but there are some constants also. But we can use the replace the conventional sources to the renewable energy renewable energy options to make the zero tailpipe emission. Next is the tax and financial benefits. So if we take an EV, the government have some policies and some schemes under which they are providing the low registration fees, road tax, low road tax, or in some state there is a policy that there is no road tax for the green vehicles. Also, if you know that we, for the IC engines, we need to carry the PUC. For the EV, we do not require any PUC. So there are multiple policies and incentives offered by the government depending upon which state you are in. Okay. And next is the petrol and diesel use is destroying our planet, as I have already discussed that if we compare the efficiency perspective, the electrical vehicle can convert around 60% of the electrical energy from the grid to the power the wheels. And if I talk about the petrol or diesel, in this case, they can only convert 17 to 21% of the energy stored in the fuel to the wheel. So most of the part is dissipated as a loss. So that is the wastage of around 80%. So it is more convenient to use the electrical vehicles. Next is the electrical vehicle are easy to drive and quiet. As in conventional IC engine vehicles, we have different systems there: clutch, brake, accelerator, and we need to make some combination to drive that vehicle. So that type of situation is completely avoided in the electrical vehicles, because there we have just a accelerator, a brake, and the just a steering to control. So when you want to charge your vehicle, just plug it into the home or public charger. Or electrical vehicle are also quiet, so they reduce noise pollution that traditional vehicles contribute to. Next, the convenience of charging at home. So imagine that a busy at a busy fuel station during the peak hours, and you are getting late to reach your workplace. So these problem can be easily overcome with an electrical vehicle. Simply plug your vehicle at your home charger for 4 to 5 hours before you plan to go. But yes, there is a disadvantage. You need to plan it earlier. Whenever you going somewhere, you need to take care of it. So if you are able to get a charger where you park at home, it is very convenient to plan your journeys in advance. And what if you forget to plug in your machine someday? So now, as the technology's revolution is going on, we have the fast charger options now. Most of the government of India is also doing the installing the charging infrastructures for the EV, to so that the anxiety of going the long drive or long journey can be avoided. So it is a great way. And now next, the final is the no noise pollution, as it uses the like motors. So no engine means no noise. the electric motor function is so silent that you need to peek into your instrument panel to check whether it is on or off. And electrical vehicles are so silent that manufacturer have to add false sound in order to make them safe for pedestrian. I give the recent example. I have the Ola scooter. Okay, so I recently got a software update of Move OS 3, and in that Move OS 3 I got a theme option where I can select the like classical scooter sound while I was accelerating. Otherwise my vehicle do not have any sound. So this is the feature we have to give for the safety of the pedestrian also while we using the electrical vehicles. So look at the architecture of a EV. So the main part of is the drivetrain system. So drivetrain system basically consists of a power converter, the motor, and the transmission drive shaft, which basically drive the wheels. And the power converter is basically controlled by the drive control signal, which we give through the steering the wheels or by acceleration or by pressing the brake pedals. These are the all inputs from the users to the drive control signals, and that basically decide the power converter operations. And the main part that driving this complete system is the energy source, which is basically a battery bank, which is the most of the major cost of the EV is in the energy source, that is a battery pack and the source charger. Source charger can be on board. On board means it is already installed in the vehicle, or you have the separate dedicated charger for your EV. So let us look at different components of the EV. So we have the electric traction motor, which basically drive the wheels and which is the main moving part of this vehicle. And the power electronics converter, which I just talked, it basically takes the power stored power from the battery bank, and that make the compatible power for the motor whenever the power converter basically receive the control signal from the controller. Then we have DC-DC converter, we have the thermal cooling system, because battery bank are also the um, chemical cells. So whenever we use the high amount of power from the battery pack, the battery pack get heated. So we need to maintain the temperature, certain temperature. For that we have the thermal system, which is basically a cooling system. And we have the, you can see the yellowish traction battery pack, which is in the carpet of the in the carpet of the vehicle. Then we have the external charging port to charge the vehicle, to store the energy in the battery banks. Then we have, to increase the torque, we have the transmission connected to the traction motor. And also we have the, if we have the onboard charger, to basically charge the auxiliary supply basically used for the headlamps and different lighting system to control the windows motors. This is the auxiliary battery which is used for that systems. So now let us look at the different types. As of now, you only know the terms electrical vehicle, but it is not like that. It has a different types. First, if I talk about the battery electric vehicle, is basically fully powered by electricity. Means that vehicle does not have any other source of energy or source that drive that vehicle. So fully powered by the electricity. So they are more efficient compared to the hybrid and plug-in hybrids. Next one is the hybrid electrical vehicles, which is basically categorized in the two category. One is the hybrid electrical vehicle. The vehicle uses both the internal combustion engine and the battery powered motor powertrain. And petrol engine is used to both to drive and charge when the battery is empty. So these vehicles are not as efficient as fully electric or plug-in hybrid electric. And next one is the plug-in hybrid electrical. Basically, it uses both internal combustion engine and a battery charge from an external socket. So what is the main difference between the hybrid electrical vehicle and plug-in electrical vehicle? So in hybrid electrical vehicle, we cannot charge the battery bank from the external source. The battery get charged from the engine itself. And in plug-in electrical vehicles, we have the separate source. For the engine, we have the fuel tank, and for the motor drive, we have the separate battery bank, and we can charge that battery bank separately from the any plug. So the plug-in electrical vehicle are more efficient than the hybrid electrical, but less efficient than the BEVs. And last one is the fuel cell electrical vehicle, where basically we use the fuel cell in that to produce the chemical energy, and basically hydrogen energy is converted into the electricity. So let us look at the architecture of the battery electric vehicle. It basically it also known as the all electrical vehicle, AEV also, and the electrical vehicle using BHEV technology run entirely on the battery powered electric. If you look at the main components of this, then the electrical motor, inverter, battery, control module, and drivetrain are the main component. And if we just understand the basic principle of working, then the power for the electrical motor is converted from this DC battery to AC, and as the accelerator is pressed, a signal is sent to the controller, and the controller adjusts the speed of the vehicle by changing the frequency of the AC power from the inverter to the motor. This is nothing but the basic principle we have studied in the machines. If we talk about the induction machines, we have different type of control there: voltage control or frequency control or V by F control. We use it just utilizing that principle or that study in this practical in any practical product. And the motor then connect the leads to the turns of vehicle through a cog. If the brake are pressed, there is a concept of regenerating braking. So during the deceleration period, the motor becomes an alternator and produce power which is sent back to the battery, which basically eventually give the extra range to us. So if I talk about the examples of BEV in our India, then Morris Garage. You already know about the short name is MG. MG Hector. Uh, just just to let you know that MG is producing the ZS model. Tata produces Nexon, and from earlier than the Nexon, they have produced a Tiago in the market, and the first one in Indian market was the Mahindra from the Mahindra E20 Plus. Then now we have the Hyundai Kona, and now Mahindra Verito. And as the in Delhi right now, the Auto Expo is going on, and lots of EV are launched by the Tata, Hyundai, MG, and different other manufacturer also. Now look at the architecture of the hybrid electrical vehicle. As I was telling you that hybrid electrical vehicle does not have any external plug-in point to charge the batteries. Battery get charged from the engine itself. So it has only input as a fuel tank. So HEVs are also known as a series hybrid or parallel hybrid. HEV have both engine and electric motor. And if you look at the main component, then they have the engine, electrical motor, battery pack with controller, inverter, fuel tank, and a control module also. So the fuel tank supplies the energy to the engine like a regular car, and the battery run on the electrical motor. Both engine and electrical motor can turn the transmission at the same time. If you look at the in current market scenario, example in our India perspective, then we have the Grand Vitara hybrid, Sia's hybrid. That are the examples of the hybrid electrical vehicles. They have the small amount of battery pack, which can provide you up to like 25 kilometer or 20 kilometer of range. But while you are running the vehicle, that support in the terms of torque, so the mileage get improved of the vehicle. So these are the hybrid electrical vehicles. Next, I talk about the plug-in architecture of a plug-in hybrid electrical vehicle. Then plug-in hybrid electrical vehicle have the separate input for the, like, you can have the petrol tank, or mainly hybrid or PHE vehicle have the petrol engine. So fuel tank you have, then you have the separate battery pack that you can charge separately. So in HEV, uh, the battery bank and the engine produce the power combinedly. But in PHEV, you have different modes of running. You can use all electric mode or a hybrid mode. In all electric mode, in which the motor and battery provides all the car energy, or in hybrid mode, which both electricity and petrol diesel are employed. So you can see the components, and if we look at the working principle, then the PHEV start up in all electric mode and make use of electricity until their battery pack is depleted. Once the battery get drained, the engine take over and the vehicle operates as a conventional or non-plug-in hybrid. Or you can operate in the hybrid mode. So again, we have the recently, if we look at the Hyundai Sonata, Kia Optima, Volvo XC90 T8. These are the models which are the example of PHEV. Next, we have the fuel cell electrical vehicle, FCEV. So it has the it use the basically are also known as a zero emission vehicle. They employ fuel cell technology to generate the electricity required to run the vehicle. The chemical energy of the fuel is converted directly into the electric energy. So if we look at the components of this vehicle, then we have the electrical motor, fuel cell stack, hydrogen storage tank. Then we have the also have the battery with the converter and controller. Like the company which has produced the fuel cell electrical vehicles are the Hyundai Nexo or Honda Clarity and Hyundai Tucson and Toyota Mirai. These are the models which is the examples of fuel cell electrical vehicles. Now let's bust some common myth about the electrical vehicles. So first one is electrical vehicle are uneconomical. But the fact is, every new technology follows economic path where the initial upfront price is higher. Whenever something new is come, its cost is always higher.
एक्सक्यूज मी सर, आपका फिर से वो नोट नोट ही आ गया सर सामने, वो मेन स्लाइड जो है वो नहीं आ रही है, स्पीकर नोट बड़ा दिख रहा है और वो यार ना
सर अभी दिख रहा है?
यस सर.
Okay. So I was telling that whenever the new technology come, in initial price is always a higher one. So earlier, when we do not have the like touch screen phones, when the touch screen phone comes in the market, the price of that touch screen phone was very high. But the as the time passes, then the now the cost of that touch screen phones becomes very less. So likewise, every new technology follow an economic path where the initial upfront price is higher, and this reaches a maximum, then decreases, then people adopt this technology commonly. The electrical vehicle are the same, but the higher price point are quickly changing as the cost go down. As we know that government is producing for the FDA investment, also collaborating with the different companies, R&D departments, just to cut down the cost to producing the cell and to help with the initial cost many subsidies and incentives are offered by the government. Next is this, it takes too long to charge. So the fact is, the time of electrical vehicle charging depends upon the type of charger use. We have different type of chargers, level 1, level 2 and DC fast charger. Level 1 charger are the slowest one, and level 2 is much faster than the like conventional level 1, and the DC is the fast charging, which is basically charge the vehicle at the voltage about more than like 300 volt. And as per the Bureau of Energy Efficiency and currently available electrical vehicle across the vehicle segment like two wheeler, three wheeler or four wheeler, we can charge from 0 to 80% in around 1 to 5 hours from slow moderate charger. While using the fast charger electrical vehicle, we can charge in less than 1 hour now. You also know that you everyone also know that in our mobile technology now we have Oppo just have introduced the 250-watt charger. You can imagine your phone is charging in less than 5 minutes, while in earlier days our mobile get charged in like about 2 hours and 2.5 hours. Now it's taking only less than 5 minutes to charge completely from 0 to 100%. So same technology, the fast charging technology also adopted in the electrical vehicle segment also. So you, if we use the fast charger, our vehicle get charged from 0 to 80% in less than 1 hour. And basically the fast charger are mainly used for the four wheeler only. Next is the electrical vehicle batteries will only last a few years. That is the biggest myth that we all keep in mind, that while we purchase the electrical vehicle, or we either we are planning to purchase electrical vehicle, we always look for that the battery cost is too high. After 1 or 2 year we need to change the like we have like very big kharcha of changing that uh, batteries. So it is not like that. So let me break this myth. The fear of the short lifespan of battery arises when we start comparing it with the batteries of our smartphone. The battery used in electrical vehicles are superior and designed to offer a long service life. And many manufacturers are providing the warranties of 5 to 8 years on batteries. If I talk about the Tata itself, on the Nexon battery bank, they are providing 7 years of like warranty on the batteries. So you do not need to worry about that. Yeah, I agree that as of right now, the battery cost is high, but eventually, as we are adopting this system and adopting this technology commonly, so eventually the price get more than, if you can say, if just take an example, let's suppose the battery price is 100. I know that in coming 5 years it will cost me around only 25 rupees. So the 75 approx cost will be reduced. Next is the emission impact of an electrical vehicle are more than the petrol or diesel vehicle. So let me talk about it. So electrical vehicle can convert about only 59 to 62% of the electrical energy from the grid to power at a vehicle. Whereas conventional petrol vehicle can only convert almost 17 to 21% of the energy stored in the petrol to power at a wheel. We need to basically convert that petrol energy to power the wheels. So only 17 to 21% are transferred to the wheels. Even CNG engines are not entirely clean as they emit the ammonia and produce the particulate emissions. While you might argue that electricity generated for the electrical vehicle also lead to carbon pollution, the amount varies directly with the how the local power is generated. And if I talk about the Shri Narendra Modi ji's government, then if the central government, India has ambitions to achieve about 40% cumulative electrical energy installed capacity from the non-fossil fuel based energy sources by the year 2030. Next one is the electrical vehicle have very low range. So it's natural for driver to be concerned about being standard with the flat battery miles from the charging station. But as the electrical vehicle becomes more commonplace, the range is increasing. As of now, if I talk about like recently, yesterday I have seen that Hyundai has launched his EV. Uh, I think it is model name is Iconic 5 and 6. So they have offering the like two models, one with the range of about 400 kilometers, and the other one is about 600 kilometers. So the electrical vehicle currently available can easily accommodate an average daily mileage of Indian drivers. What we drive daily? We daily drive approximately, if we living in a city itself, then approximately running will be around 50 kilometer or 60 70 kilometer. And as per the Bureau of Energy Efficiency, the average range of electrical two-wheeler currently available in market is around 84 kilometer per charge, which is enough for a day to day travel with a city. And the average range of electric car available in the market is between 150 to 200 kilometer per charge, but it get increase. As of, if I talk about in the 2023 or in 2022, it get increase. It is now available up to range of like 500 or 600 kilometer. So this range, when considered with the continuous increasing charging infrastructure, make communicating even intercities easier. As I was talking about it, government is focusing on it. They are electrifying the highways, developing the new charging infrastructure, and promoting, giving incentive to the third parties to install the charging stations. So this will eventually get eliminated. That the electrical vehicle have very low range. Next is electrical vehicle are slow and have a bad performance. Nothing at all. As you know that the electrical vehicle, if we accelerate an electrical vehicle, you suddenly get a power. The electrical vehicle are powered by electric motor that generates torque instantly without any gears. So as soon as you push down the accelerator, the electrical vehicle will accelerate from stationary without any lag. So I don't. I have personally drive the four wheeler of a electrical vehicle from the, that is basically I have driven the Tata Nexon. When you accelerate in sports mode, you feel like you sitting in a jet. You just drag behind the seats. So it is. I cannot say that the electrical vehicle are slow or have any bad performance. India's electricity grid is not suitable for electrical vehicle. So India has committed to have approximately 450 gigawatt of renewable energy by 2030, and the current weighted average emission factor of the country for the national grid has been nearly constant over the past few years at 0.82 billion CO2 per megawatt hour. And as the share of renewable energy increasing, the dependency on the coal decreasing, and the overall emission for the electrical vehicle will also decrease further, as government is promoting the installation of installing the renewable energy sources like wind energy, solar energy, and India has the great potential to produce the energy from the renewable energy sources. Now, next is the India's electrical charging stations are not enough. So, for that, there is already a 934 charging stations in India with more and more providers, both public and private. I have considered the 934 charging station combining the like under the Fame India scheme as well as from the third parties. So measure have been taken by the government to ensure public charging infrastructure, and the Ministry of Power provide the following minimum requirement of the local of the public charging station, that at least one charging station should be available in the grid of 3 kilometer, and one charging station to be set up by every 25 kilometer on both side of the highway roads. And the Ministry of Housing and Urban Affairs amended its model building bylaws. So as the technology is evolving, so earlier government does not having any plan for the EVs or any roadmap for developing the EV infrastructure, or earlier we have never imagined about the like bullet train, or we will going to have the high speed trains in our India. But now the feasibility is coming, so the government is also promoting it and doing work to promote and develop the country toward the sustainable environment. Electrical vehicle get damaged in the waterlogged areas and are dangerous to charge in the rain. So it is not like that. All electrical vehicles come with the compliances of the ingress protection. Basically, you know about the IP rating. That is, you only hear in the mobile technologies, that your mobile is IP67 rated or 65 rated. So it is basically called the ingress protection as a standard we use. So most of the electrical vehicles have the IP67 rating or more. Here 67 basically what it represent, the protection against two element, dust as well as water. So to give a reference, anything past 67 is generally used for specialized equipment such as a submarines. Thus, your electrical will not have any malfunctionings. You can charge your electrical vehicle in in a rainy season, or you can pass your vehicle to the wherever the water is accumulated. You can pass through it. It will not get damaged because it is IP67 rated. So it is a myth that your vehicle get damaged. If your manufacturer is providing IP67, then only it get protected. If manufacturer is not providing any standard IP standard, then eventually your vehicle get damaged. So it is very important. Now let's see the India's EV mission and plan. So if you look at the EVs history in India, so it's basically assembled and sold in country in the beginning in the mid of the 1990s, and the demand was at that time is very low. So because at that time technology is not that much mature, so everybody have the faith to adopt the system. So due to that, the demand and supply related issue, it does not come in existence in a very fast way. And these includes basically lack of domestic manufacturing ecosystem and component supply chains, limited EV option, high vehicle cost, and vehicle and battery performance issue, and inadequate battery charging infrastructure. Earlier, we do not, if we look at, if I go 5 year back, I do not have any charging infrastructure in India. Now we have. If you go into Google Map and if you search for it, charging infrastructure or charging station near me, you will find the several third parties as well as the government charging infrastructure in your Google Maps. So the as the time get fast, we are basically going towards the technology revolution. So at that time, the government was undertaking short-term and isolated initiative to promote EV without the guidance of the vision document or roadmap for the EV sector. As I already just discussed, that earlier government was not having any plan. So in 2011, to escalating the environment problem and remove barrier to greater adoption of EV, so Indian government, in which a department is there, the heavy industry, which launched the National Mission on the Electric Mobility (NMEM) in 2011. The main motive of that program or that scheme is to basically promote the domestic manufacturing of the EV and widespread adoption of the hybrid electrical vehicles, and initiate the target of total EV sales to 6 to 7 millions units by the end of the 2020. And the National Electric Mobility Mission Plan 2020, 2020 end of this name is basically the including the name of this mission, but it was basically produced in 2013, but name was the National Electric Mobility Mission Plan 2020, which basically offers the create the demand for the EVs. So the mandatory was that government is promoting the adoption of the EV in public transportation, and offering the incentive of the reduced price and tax exemption to buyers of various type of vehicle. Also strengthening the manufacturing ecosystem. If government does not provide the facility for the manufacturer, then who will produce the EVs? The cost of EV is already high. So also support the various research and development, including the international collaboration for designing the cost effective solution for the battery charging or any technology, and also augment the existing infrastructure of a power generation and transmission. So basically it focuses on the charging infrastructure in the Indian power grid, and finally basically aware the public about the basic EV technologies and their what are the different schemes available with the government, so that can um make the people aware about the adoption of the EV. So in 2015, this plan is further basically promoted, and the FAME India scheme is produced, which is basically faster adoption and manufacturing of electrical and hybrid vehicle in India. So it basically have the two phases. In phase one was between the 2015 to 2019, and FAME 2 right now, which is going on, which is started in 2019, and it will end by the 2024. So if you look at the aim of these two FAME schemes, so earlier in FAME 1 scheme, the main aim is to reduce the dependency on the fossil fuel. So basically most of the incentive is provided in terms of buying a electrical vehicles, and mainly emphasis provided on the provide affordable and environmental friendly public and private transportation for masses. And focus area was basically technology development, demand creation. First we need to create the demand, then only the uh, EV get adopted. So pilot projects are produces, charging infrastructure was developed so that the EV buyer get the confidence of buying the EVs. In FAME 2, aim was to encourage the faster adoption of electric and hybrid vehicle. As you can see, this effect of this scheme in last 2 years, that now in every city, we wherever we see out of 10 vehicles, at least we see the 2 to 3 vehicles as a EV, and mainly emphasis on the electrifying public transportation, including the shared transport. Recently, like Gujarat government and Delhi government has included the DTC buses, basically full electric DTC buses in their public transportation. And focus area was the upfront incentives to on the EV purchase, like providing the subsidies under the FAME 2 scheme, where you getting about for the two wheelers, earlier in FAME 1 scheme, which was according to battery pack available in the EV, which is a 10,000 per kilowatt. Now in it is revised in phase 2, which is a FAME 2. In FAME 2 it is about 15,000 per kilowatt. And also every state government also having their own EV policies. Our Rajasthan government in October 2020 2022, they have also produced the EV policy in the state of Rajasthan government, which basically says that they will return the SGST amount. We have the CGST and SGST. They will completely refund the SGST amount on of the electrical vehicle you will purchase. So upfront incentives on the EV purchase, charging infrastructure is selected cities and along the major highways. An amount of rupees approximately 110 billion has been allocated to the completion of the work proposed under these two phases, FAME 1 and FAME 2. And as I said, majority of the incentives were provided to the buyers of EV while buying the EV. They're providing the in the form of, we already know that subsidy, in the form of subsidy. And also GST is reduced to 5%. Otherwise, if you look at the GST slabs, for the electrical, any type of electronics or electrical item, you have 20%, 28% of GST on that. But especially to promote the EV adoption, they have given the good and services tax under the 5% and allow the sale of electricity for the EV charging as an incentive to attract private investment. As a third party, whoever want to install the EV charging infrastructure, the government is also providing the incentives to that third parties and issuing notification for exemption of permits. So you do not need any permit to operate in case of battery operated vehicle. You not required any permit to drive through any other cities. So the main requirement to eligible for this incentive, it's the vehicle should be manufactured in India and to be registered as a motor vehicle. With, you cannot suppose example, you want to own the Tesla in India, so you cannot avail this schemes facility from the Tesla EV because it is not manufactured in India. So government have issued the license to the OEMs and some manufacturers to authorize them to manufacture the EVs according to the government standards, and they should be provide the minimum this time this part of time of warranty on the battery side or on vehicle and everything. So then only you can have the incentives from the government scheme. So these are the EV sector key achievement under the FAME scheme. So we have 61 original equipment manufacturer. Basically, we known as in short form OEMs, and we have registered of around 245 EV models. But currently in FAME 2, we have only 137. These 245 I have included FAME 1 FAME 1 scheme and FAME 2 scheme, but currently as of now only approximately 137 models are in the EV scheme. You can go and check these which type of model from which company under the FAME 2 scheme. You can go on the Ministry of Heavy Machinery and you can go into the FAME 2 section. There you can find which manufacturer providing which model. And the incentive amount to INR approximately 3,542 crores given by the government as an incentive, while the we as a citizens of India buying the EVs. And total of approximately, it it counts going to be soon, it is going to be 1 million under the FAME scheme, and approximately 5,600 electrical buses deployed and supported in various states by the government, and 532 charging station installed under the FAME 2 scheme. And in recently last 6 months, government had approved the allotment of approximately 200 charging stations. And we have 3,448 retail outlet offering the EV charging facility, 214 million liters of fuel saving, and 310 million kg of CO2 reduction. This is the dashboard screenshot just I have taken today from the Ministry of Heavy Machinery. As you can see, the total number of vehicles sold in the current as of now today is 8,10,544, and we have 135 model available under the FAME India scheme 2, and fuel saving per day is around approximately 6 million, and we have approximately 214 million saved fuel in liters, and 101 CO2 reduction million CO2 reduction per kg in per day, and total we have the CO2 reduction of a 310 million kgs, and total incentive is 3,543 crores. And this, in this map you can see the different state which have the number of electrical vehicle registered. So this is all about the fundamentals of the EV technology. I hope everyone get the brief about the different types of EV, what are the myth, and what are the outcomes, and what are the future plan of the government, and what are the scheme government providing or incentive providing for the use of EV. I'm open to take any question now. If you want to get connect with me, you can scan that QR code.
Dr. Abrar, thank you very
Yes, sir.
much for delivering a very nice lecture and enhancing our knowledge related to the fundamentals of the electrical vehicles. You have covered so much. Some myths are also there among the common person belonging
Yes,
to
sir.
our country, that it will have a less average, okay, charging time will be more, and you have focused on all these myths, that these are only myth, okay, they are not
Yeah,
the reality. Okay.
because sir, knowledge is not transferred, or we are not going to in deep to get that knowledge that what we are actually.
Yeah. So your company is also manufacturing batteries, I think so.
Yeah, we have the two separate businesses. Basically, Genus Power Infrastructure Limited, which is basically, you can say that it is only focused on the metering side, as well as we have the Genus Innovation Limited, which is basically focused on the solar modules, inverters, and different solution related to e-rickshaws and batteries related.
Okay,
That are
okay.
two separate businesses.
So anybody has any more question?
Think
Dr. Abrar Ahmad,
okay, if you have later on, if anybody have any question, you can email me on abrar.ahmed@genus.in, and you can connect me on LinkedIn whenever you want to have any question regarding the lecture I have delivered. And thank you so much, sir, for giving me this opportunity to share my knowledge with the all participants.
so, Dr. Abrar Ahmad, thank you very much that you have spared your golden time with us and thus enriched us with the knowledge. And we hope tomorrow also you have one lecture, and tomorrow also you will be delivering with such a nice lecture, I hope. And thank you very much once again.